Hello and welcome to a Math Warehouse video on SAT prep involving the equation of a circle. Here we go. In the xy plane, a circle has center C with coordinates h, k. Points x and y lie on the circle. Point x has coordinates h plus 2, k plus square root 50, and xcy is a right angle. What is the length of xy? I believe it is very easy to overcomplicate this question, and it's a little bit of an annoying question. On the annoying meter from 1 to 10, it's maybe a 7. I think the first thing you should do is draw a picture of this problem, and this picture here describes what they're talking about, right? Circle center C, it has a coordinates of hk. We've got x and y on there, and then they give us coordinates and they tell us that xcy is a right angle. Whenever you see right angle, you should be immediately wondering, and you see a circle, there should be things coming to your mind like, is a Pythagorean theorem going to be involved? Is there going to be something involving the central angle? Now I'm going to just label x is h plus 2, k plus square root of 50, and we have the right angle, right? And so what they want to know is what is the length of x to y if we were to draw a line from x to y. Now, as you can see, cx is a radius, cy is a radius, so they will have the same length. And if we can figure out the length of one of these, then we can set up a right triangle and use the Pythagorean theorem to get xy, which is what we're going to do. Now, I recommend a strategy for questions like this. You could use h and k and plus 2 and plus 50, plus square root of 50. I would prefer to make up real numbers for h and k because any numbers you make will work. I'm going to make some nice easy numbers. I'm going to make h1. I'm going to make k3. All I did was substitute 1, 3 in for hk. The math will be the same. We're going to do in this question with the top picture, you're just going to have algebra that cancels out, and I prefer to work with numbers. So whenever you can, just try to substitute numbers in for variables. So now we have to figure out how far is this radius. How far is c from x? What is its length? And we can use the distance formula for that. A little reminder on the distance formula, it is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're just going to take these numbers and throw them in for x2 and x1. As you can see here, 3 minus 1, x2, which 1 plus 2 is 3, minus 1 is what we have here, and then y2 minus y1. So what's y2? It's 3 plus the square root of 50 minus 3. And once we simplify this, we can see the math for it, you'll end up with the square root of 54. So that's how big this blue radius is, a square root of 54. So since radii are equal, you can see that this is square root of 54, this is a square root of 54. Remember, they said that xcy is a right angle, making this a right triangle if I were to draw a line from x to y, and you can use the Pythagorean theorem then to find this. A squared plus b squared is c squared, and we're trying to find that c. Square root of 54 squared plus square root of 54 squared equals what we're trying to find, c squared. Square root of 54 squared is 54. This is 54. You end up with 108 on the left, and then you take the square root of both sides, and you will find c, as in the side we're trying to solve for, from x to y, is the square root of 108, and you can simplify that to 6 root 3. Okay, so the final thoughts I'll leave you with is, anytime you see right angle, I mean, they're giving you that information for a reason. It's not necessarily the Pythagorean theorem, though odds are a little more likely that's that. It could be, you should also be thinking, hey, it's a right angle, we have a circle. Do we need to worry about the measure of this arc? But that's this question in a nutshell. The other big takeaway I would say is that whenever they give you a lot of variables like this, hk and h plus 2, k plus square root of 50, you can just substitute in numbers to make your life a little easier. The math would end up being the same. Like if you did the math down here, the h's and the k's would substitute and subtract out in the same way that 3 minus 3 went away. If you did h and k, you'd end up with the square root of 54 in the same way. All right, that's it for this question.